Now, I want to see if we can figure out how this Focus Appearance Success Criterion works. I have been in discussions over the last couple of days to see, if we can make this better and easier for people to use. And now the example that I have here is the Microsoft logo. It's from Microsoft.com. It's like the first thing that you would test, testing the success criterion. And one of the things that the person that sent that in was like the hover style, the focus style, does not meet the success criterion 2.4.11 focus appearance. And obviously, so I was like, that doesn't feel right. And I think it probably, like, my gut feeling is that it should meet the success criterion. So let's figure out what it is. So this is the hover. I captured that using polypane. I just selected the A element, and we get to that in a second. And in a focused and non-focused state. So this is the focus state and the non-focus state, and this is the focus state. So we have this dashed outline around it, and it's a dark black, so it meets any color contrast success criteria that you would think. The exact color is, let me see, 26, 26, 26 in hex. That's super sufficient, like 15.13. So don't need to really think about that right now. So let's go through the success criterion. So when the keyboard focus indicator is visible, there is a focus indicator visible, one or both of the following are true. So let's say we can take them one by one because they are independent from each other. It should only say at least one is true, but yeah, one or both, it's the same thing, I guess. The entire focus indicator meets the following. Now let's go to the definition of focus indicator so we're sure that we understand what's going on. Pixels that are changed to visually indicate when a user interface component is in a focused state. So as we have seen from my professional animation of showing and hiding a layer, it's only the outline there, like the dashed outline. So what we can do is we can just use the divide layer effect, and that will basically hide the logo for now. So we can concentrate on like what are the focus pixels. Awesome technology. So this is our focus indicator. And it's only the pixels that have changed. Pixels that haven't changed are not counted as the focus indicator. So if we zoom in a little bit, and we go to the top left, let's zoom in a little bit more, and I left the grid lines on so we can see, what is a pixel and what isn't. So if we go to the image layer, if we only show the non-focused layer, we see that we have here the, let's get back to normal. We have here no pixels, and then these are the pixels that change, right? And we can already see that we have like shaded pixel, gray pixels here. So that's interesting. And this comes from probably anti-aliasing, and I made that on a 1x1 1 pixel screen. So, it's 72 dpi, it's box standard stuff. There shouldn't be anything that like interests us here. So let's go to the divide view and say, okay, now we have that. Don't need the sidebar anymore. Let's go back to our success criterion. So it says the entire focus indicator meets the following. It encloses the user interface component or subcomponent that is focused. So let's go to enclosed first. Solidly bounds or surrounds. I assume that because only the change pixels count, this is not a solid bound, whatever that weird name, I think, but yeah, it does it. So it needs to be in one continuous line, basically, around the thing. If it's broken up, it doesn't count as encloses. So this first block doesn't matter at all. But we will get into user interface component here in a second, and that says a part of the component that is perceived by user as a single control for a distinct function. Now, the question is really if only the logo is seen as a distinct function, or if like the whole space, white space, also counts. I'm not super clear on that. So this all doesn't count on the first count because it's not what we're talking about. So we need to look at the area. So we basically now have to do math because that's always a good thing. So an area of the focus indicator meets the following. So we have small areas here in the focus indicator, and what they mean, at least how I understood it, is the combined area of all focus indicators, if that makes sense. I mean, yeah, it already says like that all changed pixels count, so that's good, but yeah, it doesn't really make clear that it's a combined area, and might not be. If not, please let me know. So an area of the focus indicator meets the following. It is at least as large as the area of a 1 pixel thick perimeter of the unfocused component or subcomponent, or is at least as large as 4 CSS pixel line along the shortest side of the minimum bounding box of the unfocused component or subcomponent. This is like a super easy sentence to read. So is it at least as large as an area of a 1 pixel thick perimeter? I don't know. I mean, if we take this whole image, which has the whole like link in it, as the user interface component, then it would need to fill all the pixels around the perimeter, as it says. And that would mean that because this is first not on the perimeter and it has gaps, wouldn't meet that. So, or it is at least as large as a 4 CSS pixel thick line along the shortest side of the minimum bounding box. So again, this is, let me look at my notes, because I totally have notes about this. This is 54 pixels in height. So 4 times 54, that would mean that we need to have an area 4 times 54, 216 pixels. That's what we are looking for. So 216 changed pixels. Or if we go the perimeter route, it would be 54 plus 137 plus times 2 minus 4. Those would be 378 pixels. So out of the bat, 216 pixels is less. So we can concentrate on that. The smaller number counts for this. Now, one of the questions that I always have is, and I didn't get a really solid answer, is like if we look at only the unfocused version here. Zoom out a little bit more. I can't know as a user if the bounding box is just this section or if it is like the whole link because I can't see the link. It's in a white thing. I mean, in this case, it's actually ahead of, on top of like an image and between the browser Chrome and the image. So, you know, I mean, you could assume that it goes up and down, but I don't think there's like anything that really says that. So if we use our tools to see that, then we would be here at 23 by 108 pixels. It's much lower. So then if we go 23 by 108, 3 times 108 plus times 2 minus 8 minus 4, sorry, is 258, which is much smaller. And if we go the 4 times the smallest size, it's 4 times 23, which is 92 pixels. Now, the difference between 216 and 92 pixels is a lot. So, but, you know, it's still like, and if I would say only this counts, and then we look at the focused image, I would say, yeah, clearly there are more than 96 pixels changed. For 216, I don't really know. I have to figure that out. And so what we need to do is, I guess, counting the pixels. And the pixels need to have a couple of like other things for them. They need to have a contrast ratio between 3 to 1 between the same pixels in the focused and unfocused state, so against white in this case, and a contrast ratio of 3 to 1 against adjacent non-focus indicator colors, which it has. So that's already like, okay, so, but if we have enough pixels that have a 3 to 1, we also have enough pixels that meet this because the colors are the same. The white adjacent to the focus indicator and the white behind, in air quotes, the focus indicator, they are the same color. So it's the same number that we need to reach, and that number was again either 92 or 216. So 92 or 216. So let's take a look, shall we? Oops. So now I'm going to count. So I will count from here. These are 5 pixels, and we have those in all the edges. So that means we have already 20 pixels. I get something where I can make notes here. So there we go. So we have the corners, 20 pixels. And because I think the top and the bottom, they are super similar, right? If we could look at that, the contrast, yeah, I think the top and the bottom and the left and the right are the same colors. I think we just can assume that for now. So we make it like not as tedious as it could be. I don't know if that's true. If that's wrong, then you know, we have to recount. Top border, and then we have left border, and then we count that twice. So let's see. So I have my little tool here for measuring contrast. So we have 3 here, and then we have one that does not have enough contrast. I see that, but theoretically I need to check that just to be sure. Then we have another 3 that meet color contrast and 1 that does not. So now we have 6. Let's do 3 plus 3 plus. Then we have another 3. And I think this is probably like a similar color. Yes. It's not. This is a 7:1, so we're getting a little bit less. So these are also 3 plus. Here we have. So 1, 2, 3. Probably should have a way to mark where I am. I do not. So I will just push it to the left. Then we are here. So in this case, it's this pixel which meets the color contrast, and this does not. So we have 3 pixels. Again, like this is super exciting. Here we also have 4.29 almost. It needs to meet 3:1. So yeah, that meets. And here we have 2.27 to 1. So that does not meet. So we have another 3 plus 3. Moving it to the left. Then we have 3.45, that counts. Then we have the 2, that for sure count. And on the right we have 1 of 278, so almost. Meeting, but not quite. So this is also a 3. Then we have this one, and I think now it goes back. Like, it's interesting that gets darker in the middle and then lighter at the outset. Yeah, this is basically flipped. So these are also 3. And now I'm going to just quickly check that none of those light ones meet the success criterion, and they don't, of course. So we have 3 for this. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, this actually goes wider. Oh, see. And I lost my place, so I will start from the beginning. So we have 1, 2, 3, 4, 5, 4, 5. 1, 2, 3, 4, 5, 6. 6, and then we have 7. And we have 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So if I put that in my calculator, it says 75. So is 75. That worked well. There we go. So we have 75, and that comes times 2. So that is then 150 pixels. Still only 170. So we can't still be sure that we make it. I mean, if we take only the smaller one, the 4 times 23, that's only 92 pixels. We already met that, but we need to meet 216. Now I'm sure we're gonna do that, but we should count the 3 tuples here and see if they meet the contrast, just to be sure. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9 times 3 if they all meet the contrast. And now we go and we see this doesn't, that one does not, that one just barely does. So we have to add 1 here, +1 for that one, because we only counted 3 here. So we need to count another 1 for that. So these are both 939393, and they just meet it. So this is actually one where you have 4 that conform. And then we have here 412, and here we have 238. So these are 3 again. 3 again. And not this one, yeah. So yeah, 3 and 3. So I have one more, which is like, that's fantastic. So we have 9 times 3 is 27, plus 1 is 28, times 2. So 28 times 2 is 56 pixels. So we have 20 plus 170, 20 plus 70 plus 56 is 246 pixels. Now, this conforms, right? So so we said it should be, I didn't put that in here, and I don't know why. It's either 4 times 45, which is 216, not 45, what did I say? 54 times 216, and it's larger than that, or it's 4 times the smaller, the 23, which would be 92, and it's larger than both, but just by a hair, like by 30 pixels. It's not like this is a big difference there, but you know, this is also like a very common use case, and I had to like dig deep into the second area. And there are still a couple of things where I think it's harder than it should be with the success criterion. For example, it says an area of the focus indicator meets all of the following. Now, these are many areas of the focus indicator. It's not one area that is that big. So does that really count? I think yes. And I think if you go into the understanding, there's probably an example there. But I always only go from the like the thing that is in the specification, because that's where people get the stuff from, you know. I mean, if I go to the understanding, there's probably a dotted line somewhere. So this is not a dotted line. This is a dotted line. So it just says it meets the focus area, but it's actually funny that there's no real calculations in here so far. So where is the 1 pixel dotted line? And here maybe. This is also a solid thing. This is an unusual shape. Oh, they do not have that. Is that what's happening? Apparently. So yeah, lots of examples, not the one that I was searching for. which is usually how those understanding documents go. I mean, I can look at dashed or dotted and see if I find something dashed. As a dashed or dotted line, it can meet this. It cannot meet this primary consideration. This is like clause 1. If we go back to the SC, it says first. So, however, a non-solid line can still pass if it meets the area calculations for the size of the focus indicator. So, yes, discuss in more details on the area of focus indicator, which we can't click on. Where is area of focus indicator? There we go. An area for the indicator using calculation for perimeter, and the second minimum based on the short side of the control system will restrict where the indicators are placed, providing 2 methods to calculate a minimum area. So this is also something that I do not understand, because they say it's a 1 CSS pixel thick perimeter of the control in its unfocused state. So, and they say border, but the border goes around the component in CSS, at least if you're using the old style box sizing, which, I mean, there's nothing that says here otherwise, right? So I can assume that. So that would actually add a pixel on either side. Like if I have 100, like here, 90 plus 90 plus 30 by 30, and I put a border around it, it will grow off that border. So it would actually be, the border would be 91, 92 plus 92 plus 32 plus 32. And then you would remove the 4 corner pixels, and then you would not get to 236. So I don't know. It's like it didn't bother to really explain that. Yeah, and there's nothing that says like, oh yeah, this is how you count dashed and pixel line, because this is from a Chromium browser, like the screenshot here from a Chromium browser. It might render different on your Firefox, on your Safari. I don't know. So counting pixels doesn't sound like the best idea to me, but it's what we have now. So this will be fun. So yeah, I hope that everything I did here was correct. And that so my assumption is that the 92 pixels is the one that we need to meet, because that's the visible size of the component. And so if that's true, I wouldn't have all the calculation stuff. But I'm not sure from the text, because it actually doesn't say that it doesn't say one way or the other, right? So it's like I don't know. And let me quickly open it again. Let's go to new features, go to Focus Appearance. So yeah, and it says an area, but it should be the combined area of the changed pixels, because it's not, or it should be the area of the focus indicator, not an area. I think that's just doesn't make any sense to me. Yeah, and here it does not say where the minimum bounding box or the 4 pixel CSS thick line actually is indicated. Like here we have the minimum bounded box. We can go here, the smallest enclosing rectangle aligned to the horizontal axis within which all the points of a shape lie. For components which wrap into multiple lines as part of a sentence or block of text. The bounding box is based on how the component would appear on a single line. So yeah, make of that what you want. So yeah, I think this is super complicated, but this is what you need to do if you're unsure how it is, and yeah, if it's only like the small, if this is the height times 4, if this is the area. Oops, I don't have the right tool selected. Let me undo that really quick. So if you say, okay, we only need to have this size of the this size for, yeah, this is obviously like less than what is going on here. But if you zoom out and you say, okay, is this 4 pixel? Oh, I can't do that like this. So I do this again. Like these 4 pixels. Is this basically red shape? I can make it red if I can do that. So take the bucket to the side. Oh, I have to actually show this and do normal. Let me add a layer. Oh, this demonstration is already too long. So let's make this like bright red here on the left. Do all the black contrasting pixels in here, are they enough to fill this section? I don't think you can do that. Like with your eyes, it's pretty hard. And I mean, if you visualize it that way, I mean, you have these and then you put them closer here. But even then, I mean, I came to a difference of what? 30 pixels towards what needs to be done. This is like, you can't eyeball that. You can't eyeball that. That's just the, and if someone tells you that you can eyeball it, you can't. You can't. It's just hard, because that's not how our brains are wired. So yeah, I mean, you can take that over here, copy that over there, and then you can cram these in, but then you still need to check like what meets the contrast and what doesn't, and in the end you get like just 30 pixels, which is less than half, well, it's a little bit more than half a row here, like half a like 1 pixel and a half. So that is the size that all the contrasting black dashes go into, and that's it's impossible to eyeball that. So you have to count it, and that's just the matter of the success criterion that will come. I'm very sure that there's no way around that. The working group did not bother changing anything in the last revision, and so I think it won't happen now. Thanks for watching. Subscribe, sign up for my newsletter, whatever you want to do. This has been very improvised, but that's also kind of my brand. So thank you. Bye-bye.